let's continue our review for exam 3, number 5. First, let's talk about those cards. We have 13 clubs, 13 diamonds, 13 hearts, 13 spades. So the probability here is the denominator is 52 cards, get 6 cards, is a combination. The numerator is 13 clubs, get 3 clubs, times 13 hearts, get 2. Then the last card is from 26, because the last one can't be club, can't be heart. Next video, we will talk about how to use a calculator, get those combination answer. Here we just put all the details manually calculate based upon the combination formula. So 13 choose 3 is 13 factorial, 3 factorial, times here 13 minus 3, 10 factorial. Second is 13 factorial, 2 factorial, 13 minus 2 is 11 factorial. Here the 26 chosen is 26. The denominator 52 factorial, 6 factorial. 52 minus 6 is 46 factorial. So you can continue the calculation. Now let's move to the next question. Number 6. Total has 3 departments. You have 12, 15, 16 members. For each department, we need select 2 people. One is delegate, another is alternate. So that here order matters. For the first department is 12, choose 2. This is a permutation. The second department is 15, choose 2. The third is 16 people, choose 2. So the answer should be, here is, based on the formula, here is 12 times 11. For the second permutation is 15 times 14. Because you from the first number 16, then you need to go 2, so total 2 numbers. So 16 times 15. You can use a calculator to get the answer. It's a huge number. How many ways can this be done? So that's the answer. Now we go to number 7. What is the probability of getting one tail? You toss 2 coins. So now let's just list all first. All the possible results. So we have, for 2 coins, it could be head, 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 tail, tail, head, and tail, tail. So total possible results is 4. So now let's count only getting 1, get 1 T. The result is, could be H, T, head, tail, tail, head. So you have 2. So the probability is 2 over 4. The 1/2. Also, you could write down one more as 0.5. Let's go to number 8. So you are dealing 5 cards from 52 cards. And for first one, all the face cards. So we know 52 cards totally have 3 times 4, 12 face cards. So let's do A. So the probability, so the numerator is total is 12 face cards. We need to get a 5. And the denominator, we have 52 cards, get a 5. So you can use calculator or manually. So 12 factorial, 5 factorial, 12 minus 5 is 7 factorial. Here is 52 factorial, 5 factorial, 47 factorial. So here, let's see here. And 5 factorial cancel out. And so let's go. Here is 12 times 11 times 10 times 9 times 8 times 8. Because then 7, 6 times 6 all just cancel out with this 7 factorial. So similarly for the numerator or denominator, I'm sorry, here is 52, 51, 50, 49, 48. So you can continue work on that. Now let's do B. B, the probability is you also need to get a 5 cards. So the denominator is 52, get a 5 cards. The numerator is you have total 4 kings. You want to get a 4 kings. And one more card is not king. So remaining is 52 minus 4 is 48 cards. Get a 1 card. So here is 4, choose 4 is 1. 48, choose 1 is 48. So here is 52 factorial, 5 factorial, 47 factorial. Okay, so now let's go to number 9. What's the probability of drawing a red card or a queen from a standard deck of 52? So suppose we let A, event A, it means you get a red card, red. B means you get a queen. So now let's see the counting. So how many ways you could get all red card? So is total we have 26 red cards. You get a 2. Oh, get a 1. I'm sorry, get a 1. So total is 26 red card. You get a 1. So it's 26. Let's count. Get the queen. We have 4 queen. Then get a 1 queen is 4. But we have an overlapping A intersection B is that card is red, also a queen. So you actually have 2 overlapping. So now let's count A red card or maybe a queen is counting A plus B, the counting of the queen minus the intersection. So is 26 plus 4 minus 2 is 28. 28. So now let's do the probability. So the numerator just 28. The denominator is 52. We need to get just one card. So it's 52. So 28, 52. So it's equal. You can keep going. Now let's do number 10. So we have the container has 25 from 1 to 25. So we have ball 1, 2. So the number 1 ball, number 2 ball. So the number from 1 to 25. So you need to compute the probability that a number drawn is even or multiple of 7. So you go get a ball from the container. So event A is even. That ball numbered even. Event B is multiple of 7. So now let's count. You get the even is among 1, 2, 3, 4, 5, 25. You know, we have even number 2, 4, 6, 8. So we actually have 20. Oh no, 12. So total have 12 balls numbered from numbered as even number. And let's count event B is multiple 7. So actually could be 7, 14, 21. So actually is 3. And now let's see their intersection. So because this 14 is multiple of 7, also is even. So the overlapping is 1. So now let's do erase here. So we get A or, so even here, even or multiple of 7. So A union B, we count is 12 plus 3 minus 1 is 14. So it's 14. And let's do the probability. So the sample space, you have 25 balls. So this probability is you're counting the sample space total is 25 because you get a 25. From 25 balls, get a 1. So the numerator is 14. So here is 0.56. Okay, we have 5 questions left. That will be in our next video.